All right, welcome everyone. Glad to have you with us. We've got a few people here. This is another day of ShopBot training. Today we're going to look at indexing or index machining. So this is going to learn the reason that an indexer is named indexer. Some may call it a lathe or turning, but it is meant to be able to index a part at a set angle or a set rotation. So we're going to take a look at how we could use an indexer as just a full rotary. Also going to look at what is called 3+1 machining. 3+1 machining is where you specify an XY plane of your model, then do XYZ travel in machining over top of that, and then be able to rotate the model a certain set of degrees to be able to then machine it from that angle. So that is makes it easier for an indexer, but just because it says indexer 3D training that we're doing here, what really could be done, what we're going to be going over today too, can also be done if you do not have an indexer. You just have to be able to manually index the machine or index your material to the side that you want to run the machining on. So we're going to get started first by taking a look and understanding how VCarve Pro and Aspire handles a wrapped or a turned project. So just going to start a new version of Aspire. And if we did have an indexer and we wanted to do a full wrapping or a full turning on this, we have the option here for a rotary job. And just centering in the length of the turning that you have, or the post or the cylinder. Then we have the diameter, and then the location of where you're going to zero, to the top of the cylinder or to the cylinder center of axis. So this is kind of the same thing that you would have on top of material or table surface. Zeroing the X and Y datum position is the lower left. So with an indexer, this top left and the lower left is really the exact same point when using an indexer, because this plane across the bottom is wrapped around and is the same plane that is across the top. The orientation is in what axis is the indexer parallel to, or your material parallel with. So we'll say okay to this. And then we have our job laid out here. So the height that we have here in the Y direction is really the circumference of our 4-inch turning. So the reason that I wanted to point this out is just going to do a quick import so we could see what happens when we have a wrapped job. So just going to jump over to the 3D tab and import a square. I say square, it's really a cube. And it is brought in, and right now the block is bigger than the material. So the red section here is the turning that we have entered in, and then the blue here is the maximum of the turning itself. So just to make things quick and easy, we're going to scale down the model to fit within the material. Then going to bring that straight in, and now with Aspire on the 3D view, it is brought in as our cube or rectangular extrusion here, and it has been wrapped around. So if we go over to the 2D view, and we see it's quite wider than that 4-inch, well, it is wrapped. So if you're familiar with Aspire in the grayscale, the darker points are deeper and the lighter points are at the top of the surface. So you can see we have 1, 2, 3, 4 points. And that is the outside corners of our 3D shape as it would be unwrapped. So coming over to the 3D view, over to the 3D view, and we could turn on and off this wrapping right now, automatic wrapping is turned on, and it is, like I said, just wrapping that two-dimensional object around. Turning this off now unwraps that. So we get these scalloped areas here. And as I said before, this area here, this flat side, and this side over here is the same point as it gets wrapped around. So this is kind of the first thing to understand for how Aspire and VCarve Pro brings in a model to run on an indexer. So this is fairly straightforward, and we're going to take a look at the challenges of why you may choose a 3+1 machining versus a full just turning machining. So as you use an indexer as a turned job, or as this is that we have here, it's really still only a 3-axis machining procedure, to where we have, in this case, our X is our standard X values, but the Y becomes the rotational in degrees, and then we have Z. So we have 3 axes, the X, rotation, and Z. Then we have the option to do, not within this job setup, but what we're going to take a look at is the 3+1 machining. That is where we set the rotational angle, set it and kind of lock it in place. Then we do an XYZ travel over top of that. And the only thing that the rotary indexer is being used for is positioning it and locking it into the degree that we want to machine at. So we're going to take a look at another model before we get into the 3+1, and just to demonstrate why we might want to do a 3+1. So I found this model on SketchUp, and we're going to bring this into VCarve. And I just wanted to show this here to show that the truck bed is a rectangular bed inside of there. So I'm going to bring that model into Aspire. And I'm going to bring it in as a rotary job. And it is capable. You are going to be able to machine this this way. Just bringing it in, I can't remember the exact size, so I'm just going to increase that a little bit in the diameter. Same settings here, and selecting OK, coming to the modeling tab, and then importing a component or a 3D model. And we have our 49 Chevy truck and bringing it in. So here we go. Right now, where you're showing the red cylinder kind of running through here is the center of the rotation. And the model size is here, so it's like huge. So it came in as a metric version, or at least I'm guessing, or maybe life size, you know, to scale model. And we want to bring that or scale that down. So I could enter in, to see if a division of 25.4 brings that down to a size that better fits within our job. So it does. It's a little bit smaller. You can see there, just to make it a little bit bigger, we'll scale it to fit the material. Once that is done, we'll say OK to that. And now notice that what we have is a V shape in the bed of the truck, and it's not squared out or hollowed out or pocketed out like you might imagine. This is one of the challenges that index or the wrapped turning using an indexer poses, where the reason that this is V-shaped this way is as we are looking straight down on top of this, this is the center of rotation right down the center of the truck, and that is at its deepest point of the truck bed. Now, as the machine in the indexer rotates around, the Z is still coming in at that same angle straight down on top, which is now producing this slanted or V-shaped pocketed out area. So for an object to be able to 3D carve this in the complete round, a straight turning may not be the best method. You might have a couple different methods that we do, or a combination of both. So the 3D full turning is giving us a, a majority of it is correct. We got some V-shaped around the wheels, but it is getting the side of it fairly nice. The top we'll be able to get okay, and then the other side we're able to get in there and see most of that detail as well. So we're going to take a look at what we could do to be able to first toolpath this as if it was just a straight turning, and it's fairly straightforward, nothing different in X and Y. So we would do this, and here it's kind of looks a little odd as it comes in. And here is that truck bed that is completely pocketed out according to the 2D view, but not in the 3D view section. So I'm going to take a look at what's going to happen here. So first, we're just going to go in straight toolpath. Do a roughing pass first. We have another model that we're going to be working with to show how to bring it in as a two-sided machining job. So we're going to get more in depth in the roughing and the strategies of 3D carving when we get to that model. But just doing a quick roughing. All right, so that is the area of the truck bed that we were seeing that is V-shaped. So now what we want to do is take a look at how could we make it so that we could carve this section of the truck out and still have it be X, Y, Z over top of this area here. So the Z0 for this project is the lower left here. I'm going to switch this, and I'm going to come into the drawing tab, and I'm going to set X and Y to the center of rotation here. Getting a message that all the toolpaths have to be recalculated. And that's what's happening here. Now, we're not going to fully be able to preview what my strategy is here, but hopefully this demonstration will kind of make you say, oh, I get it now. So we have the X and Y0 is set to the center. We have our finished toolpath that is complete and producing this, other than we are creating this V-shaped pocketed out area within the model. So now we're going to do a little bit of a combination of 3-axis and 2-axis machining here, the index machining and just straight 3-dimensional axis. So here is the truck bed. And to add a rectangle in there, there's a couple ways that we could do it. One is you could just select the 3D grayscale and use this trace bitmap. Using that slider, moving it over to only reduce it as much as I can to still only get that bed, and apply, then close. Came in as group, so I'm going to ungroup these toolpaths, the letter G to ungroup, or coming over to the ungroup button here. So now I'm just going to run a standard pocketing toolpath of a right on this rectangle here. So coming into create pocket toolpath, the depth. Yes, so what depth do we want this to be? So if we hover our mouse around in here, so I'm going to unwrap this. going down to, it's like at 0 plane there. So let's just go down 1/2 inch. So I'm going to take that there and run and toolpath it down to 0.5. Running with a 1/4 inch end mill and create that. So now what we have is a combination of both a 3-dimensional cutout and then also a pocketing toolpath. So if we run and save both of these files out using our Rotary indexer post, we're going to get that same V-shaped pocket out of the bed of the truck. And to see that, just going to do a automatic wrapping and only going to toolpath and preview just this pocketing toolpath. And you can see how that is kind of shaped around its rotary there. So we're going to go here, reset the preview, and only going to preview the visible toolpath. And we can see out here is pocketed out, and that is our angle V shape that we really don't want. So the way we would go about doing this is saving this 3D roughing project out using our indexer post, or indexer post processor found under, I'm not sure if I have it installed by default on mine, but there we are. The ShopBot indexer, in this case, I'm using X parallel. Then for the pocketing toolpath, I would just use our standard ShopBot TC inch post processor and not have the rotary done there. I'm hoping that kind of explains, and for those of you that have an indexer and have used it, might see how we're doing a combination of both. Now, I would run this roughing pass first, or in the finishing, get the bulk of the 3D shape completed. Then making sure that before I run this pocketing toolpath, make sure that the rotation of the indexer is such that the truck is sitting upright to where the bed of the truck is able to get into the pocketed area here. And the reason that I chose to 0 to the center was to be able to make sure that the X and Y was going to be over top of the center here, because that is where on an indexer where we would 0 the X and Y, or in my case, the Y would be centered over top of the center of rotation. So that is kind of how you would use an indexer with a combination of indexer and 3D or 2D XYZ rotation over top of the part. Now, the next thing we're going to take a look at is how to bring in a model to be able to double side machine and have it completely top and bottom be cut out. So I have the full version or the full model of this car. As we see, only the top side is being viewed here. And the way this was brought in, I'm just going to say, cancel here. And I'm going to start a new project or a new job. I don't need to save my changes. And this time I do remember that the job size needs to be 6 by 3, and the model height is going to go for a double-sided machining with an X of 6, a Y value of 3, and a Z value of 2.25, 2¼ inches. The model itself is 2 inches high. So when we go to carve this, we're going to be leaving 1/8 of an inch on the top and the bottom side to make sure we're going to center the project into the material. So that's what we're going to have there, an 1/8 inch on the top, 1/8 inch on the bottom. The machine bed is where we're going to reference the Z0 from. There is a couple methods, and it's fairly hard to explain without props on why you might want to 0 both of them. Mainly, there is this option here to zero off of the same side. I'll come back to that, but I just wanted to point out that this is off of the same side. I'm not going to choose that option, but for right now, we're going to do machine bed. The flip direction sides, it really doesn't matter which of these two options you choose, as long as you flip it in the right orientation when you get this cut. So with that all completed, we'll select OK. And we have the toggle to flip to the top side and bottom side here. The difference that you know are on the top side. You can see the rulers also change kind of a distinctive color to show or indicate what side we're working on, top side or bottom side. It's very easily confused, especially when you're working on a project that has multiple features on both sides. Just you're working on both sides. It's easy to get confused on what side you're actually working on and manipulating. So just a note, one thing that I tend to do when working with double-sided and single-sided machining is most of the design I work on just on the top side. So if I knew I had a rectangle to cut on one side and another rectangle cut for the bottom side, I would place it where I want it as if I was seeing through to the bottom side. Once I have it 100% complete and kind of design time, I would then right click and move to the other side or copy to the other side. That way, if through the design process I realized, oh, the bottom side, that item needed to be moved over to the right just a little bit to match, and also the top side needed to be moved over, it just kind of helps me keep things straight and not having to keep copying and moving from one side to the other side, which I still end up doing quite a bit running with two-sided machining. All right, so now we're going to bring in the 3D model. And as I'm talking here, I think a lot of you, I see a lot of familiar names there for anybody that is new joining in. There's the chat window. Feel free to chat in and ask a question there, even if the question does not seem related to what we're talking about. Still ask the question. You may have seen me click on something that you just want to know why I clicked on it or what that really did. So comments and questions are welcome. So to import the model, I'm going to go to Modeling tab, come up to Import a 3D model. I'm going to import the car now and select Open. As this comes in, it kind of shows the block. We're not quite centered in here yet, but what we're seeing here is this is kind of our cutting plane of what is brought in. We have a orientation. We could flip and rotate that around in multiple sides. Going to bring that in as the top side. Now we have to select the model size. As I said, I already kind of knew what size this was, so I entered the job size based on what I already knew this was to be. Right here, this zero plane position is what I want to kind of focus on and look at. Trying to get an angle here of where we're going to see. And right now, this is that 1/4 inch, bigger that we had talked about, entered in the 2-inch model with a total material of 2 inches. Right now, if we bring it in, nothing is really going to get imported because nothing is seen below 0. So to change this, we have this slider bar over here, and we can see we are now moving the model up into the material. And I'm going to move that up into the material to where, at a point where we're able to get the machining done from both sides. So for example, if I have stopped it at this location and imported it, even right here, let's just say directly in the center. It's a 1-inch model, 2-inch in center. So we see there's a section right here. If we were cutting from this being flipped on the bottom side, we would not be able to get into and reach this area because that would create an undercut, and we're not able to cut using undercut. So I want to move this plane in such a way that we would be able to get to the top side and the bottom side with the bit. So picturing this side, the bit's coming down into the top. We're kind of getting around everywhere that we're able to. We'll end up importing this again, but this time we'll be importing it from the bottom side, and it would be brought in this way. And again, looking at what we're able to get to from the bottom side to our cutting plane is looking good. So that is at 1.26. That 2.6, I'm going to round it a little bit to an even 2.5, just so I could know that it's 1.25 inches. And it doesn't look like it really affected our height there hardly at all. So we're good with that. I'm going to come down and simply select OK. So now only the top side from that cutting plane has been imported. And notice the mirror, which was the, would have been undercuts, creates a straight down section of the mirror on both sides, which is something that we really don't want to have happen. But we'll discuss ways on how to clean that up and get around that. Now, if we had a indexer, it makes it a little bit easier to self-index this around. And we'll also have to explain a little bit of a manual process there as well. So now it is time to switch to the bottom side. And coming back into import the tools, I'm going to import that exact same model. Only this time, I'm going to use the bottom side. Come straight down, and our slider bar here is what we're going to be adjusting again. This time, I know that our model is 2 inches. I've already removed 1.25 inches off the top. So our depth here would be 0.75. And you can see that that plane is at the same spot on the opposite side, on the bottom side, as it was on the top. At this point, we'll select OK. And there is the bottom side of the car. Now, we're only seeing one component because it is the components on the bottom. Coming over here and toggling this to the top, we have the component on the top side. So we could really only see one side at a time. And that's how we're going to handle this, and only working with one side at a time. Now there's a couple things that I'll mention. Is the material that I chose is fairly tight and small. I chose that not because that's the actual material thickness. I chose that to be able to, when importing a 3D model, to get the most detail, clarity out of the model. It's best to keep the project small and not real large. And let me try to maybe demonstrate this so we can see. Of course, we're pretty faceted. It's not a perfectly clean model. So the facets that we're seeing here is not part of Aspire, but it's just what the way the model is created. So just for demonstrating, I'm going to take this new model, and to help maybe explain what I mean, I'm going to say 100 inches by 60 inches, also leaving the Z at 1/4 inch. Now, say OK to this, and importing that same model. And I'm only doing this just so we can help describe what is happening and how Aspire handles. Again, just making that at 1 1/4. So we could see that, we still see it's faceted, but it's not as clear as what we have here. So the way, I think maybe the best way to understand or describe what is happening with Aspire and the model is if we think of, one of those gadgets. I think Brookstone at the mall has these things with it's a little box with a bunch of needles in it, and you're able to push your hand into it. And the pins only push out where you see your hand. So that's kind of what's happening here is across our X and Y, we have a lot of, all these pixels that are here. And the smaller the job, or the bigger the job is, or the smaller the job is, there's the same number of pixels or the same number of pins. That is, when we import a model, then these pins kind of get pushed in or pushed out depending on where the model is. So in the project that I opened up that was quite large, there's a lot of these needles or pins that were just not doing anything. So condensing them into a smaller area is going to get you a much cleaner, crisper import on your 3D model. So hopefully that kind of explains that some. But now we're going to start talking about how to toolpath this. So the first thing I'm going to do is create a rectangle around the outside of this completely, just top to bottom. Now the total material, like I was saying, kept the job size smaller, but the material that I would use to cut this would be farther out here. So I would set the machine 0, X and Y in on the actual material a little bit, knowing that I might have some geometry drawn out on the negative side in X and out positive on the Y as well. And what those might be are maybe indexing pins to do a manual flip if we didn't have our indexer. So for this, we're going to take a look at the different roughing. I quite certainly have to do a roughing on this, mainly because my finishing bit is not 1 1/4 inches. I don't have 1 1/4 inches cutting length on that. So we got to make sure that I have enough room there for that. A few other things that you need to understand or pay attention to, even though your cutting length and your finishing pass, we're doing this roughing, we still have to have a finishing bit that is long enough to not cause a collision on the roof of the car when it is getting down below here. So the actual cutting length, the bit length has to be longer. The cutting length does not necessarily have to be that long because we are removing material. So for starters, we're going to do a roughing pass on this, selecting our rectangle here and coming into a 3D roughing toolpath. And removing a lot of this material, some people think like, oh, you're doing 3D, you always have to use a ball nose. Not always. We don't always have to do that. So we're going to use an actual end mill. But I always forget to explain this screen right here. So let me just cancel this again. So even though I came and clicked on the roughing pass, this other window opened up. And what that window was this set material window. It comes up once because what it's asking us to do is set the location of our model within the job space. So this darker, lighter area here is the actual model thickness, and I want to actually make that at 0.125 in the top, down from the top, because that's what we divided it up to, where we're going to have 1/4 inch bigger than the actual model, leaving an 1/8 inch on top and then also an 1/8 inch on the bottom. All right, so now when we come into the roughing pass, I'm going to come in and select a bit diameter or a bit. So for the roughing, I'm just going to use an end mill. They're able to cut a little bit faster, be a little bit more aggressive. The step over could be a little bit bigger and still be able to rough out quite a bit of this material. So I'm going to make mention or look at what we have here for our pass depth. I'm going to bump that up to 1/4 of an inch and select apply, then select. We're going to do it with 2 different ways. We're going to do it based on the vector selector, and we're going to do a Z-level roughing first, just to see what the differences are and why I am going to elect not to do a Z-level roughing. Anytime it takes a long time like that, it's calculating. I wonder what setting I have wrong. It doesn't seem like it should have taken that long to calculate that unless my toolpath simulation. No. All right, so what a Z-level roughing is basically roughing down in layers of 2 dimensions. So it might be a little bit quicker to be able to run back and forth at one set height rather than moving up and around different bits. So it might be a little bit quicker to do such a thing. But we'll see how this looks like when we preview this. So an end mill that I used here, and for those that, it took me a long time to understand, like an end mill, what are you using? Use an end mill. What is an end mill? An end mill is basically any cutter that is square, that creates a flat bottom bit. The end mill could be a spiral up, it could be a spiral down, it could be a straight cut, anything that is a non-profile type cutter is generally referred to as an end mill. A ball nose is one that is curved or has the radius on the bottom of it. So let's take a look at what we have for a preview all toolpaths. And you can see it's just clearing out and doing like an area Z roughing as just cleared out this material at varying levels. Now, one of the challenges that we would have here now is the material, just looking at this kind of as a cross section, we have the windshield that is, and the car is coming down here. If I go to cut this with an 1/8 inch cutter that only has a cutting length of, 3/8 of an inch, this step right here is already beyond that. And we're not going to be able to get that material out of there. So a couple ways around that, if you still wanted to do a Z-level roughing, is increase or decrease that pass step. So we're going to take a look at that now. So just double clicking this toolpath. And I'm going to just edit and not make a permanent change. So this pass depth, I'm going to change that to be 0.125. And since we are using an end mill, I'm able to increase the step over quite a bit and still get all the detail and have a flat bottom there. So we're going to say okay to that. All right, so now we see that we have, more layers through here. I'm not going to reset the preview just so we could watch what it does over top of our original pass and cutting. So I'll do a preview of all these tool paths. It just created more layers as it came down here. So the smaller or the shorter the pass depth is, the more layers that are going to be produced. So at some point, we could continue to decrease the step down to be able to make it in such a way that we do have enough room or enough remove for our finishing bit to get in and remove that material. But at the same time, the amount of time it took us to make all these multiple steps. We're not saving the time that a Z-level roughing would do. Now, if I were coming back into this with a hefty, bigger ball nose that is capable of coming through these layers, then yes, I would probably do it as a Z-level roughing pass. So we're going to come back into this, and we're going to change that from a roughing pass to a raster. And I'm also going to come back up and do our pass depth. I'm going to change that a little bit. I'm going to increase it because I know my 1/4" cutter is really capable of making a pass at 3/8 deep in a single pass. So that's what we're going to do. The step over, I'm still in an end mill. I'm still going to leave that up high. As the higher our step pass over is, or step over is, the faster the roughing is going to complete. This is the space between the raster lines. So say okay to that. And I'm also going to change the angle, raster direction, to be along the X, which seems to be a little bit more efficient rather than going back and forth along the Y. Going along the X being the longer axis should be a little bit faster. So now there's one more thing. Yep, I do have an allowance here. So this machining allowance is how close are we going to allow this 1/4" cutter come to the surface of the actual model. Basically, how much material are we going to leave offset around our entire model for the finishing bit to come in and clear out. So select and calculate, and this one will take a little bit longer. Oh no, it's going fairly quick. So it's still cutting in step down layers, but now we see it is removing everywhere around there. Again, I'm not going to reset the preview just so we could see what the difference is as it machines through this. We'll see the difference. So I'm just going to machine all the tool paths. So that is, now we have a 1/16 inch material left on our model to come in with the finishing bit. So just reset because we still see some of the step downs of the roughing. So I'm just going to reset this and preview all the tool paths so we can see what it looks like strictly with that 1/4" bit. So that is it. We would get a much smoother, cleaner cut if we decrease the pass over or the step over. So I'm going to just do that just so we could see the detail that we could still get out of a fairly large end mill and not using a bit. So let's just bring that down to 10%, the same that we would probably use if we were using a finishing bit. We're actually going to get a very nice, clean, smooth edge over top of the windshield, down around the hood. Just not going to be able to get into the detail around the wipers of the car or the vehicle here, but this end mill is actually going to produce a very smooth surface over top of the larger flat area. It's just not going to be able to get into the detail. We can see this is the difference of the end mill that's happening here versus happening in this direction here. So as it's moving up and stepping up over a vertical wall in this direction, we're getting these layered steps. But moving and coming over top of a contour up along over top of the windshield, since we are profiling in rastering in that direction, we're getting very smooth, clean surface. As we can see, a fairly clean surface across the hood, the windshield, and the top of the car. And honestly, we wouldn't get any smoother area or pick up any more detail using a ball nose on the hood or the top of the vehicle as if we used the end mill. Now the ball nose will create a much smoother, cleaner surface along the side here. So just going back into our roughing and going to come back and increase that step over back up to, let's just say 60%. All right, so that is the roughing. Just going to jump in and do the same thing for the finishing toolpath. Got an 1/8 inch bit selected around a vector, around that same vector pattern, and then calculate. So this will basically finish off the top section. So we're going to have 2 tool paths for the top. We're going to have a roughing and a finishing. The way I would do this if I was running this on the indexer is clamp the indexer and the material in the indexer just as it is, kind of here with the flatter, wider on top, and set that rotational axis to be at 0. So the B axis reading 0. Then these files, save these 2 files out just as a standard XYZ toolpath file, just as if it were laying directly on top of your table surface. Then once this is all done, you then issue a command, type in move B 180, which is going to rotate this block 180 degrees. Then we're going to have 2 more files that are creating the bottom side. Now we're going to take a look at how we import the bottom side or toolpath for that bottom side. So I'm going to only been working on this top side. We're now going to flip to the bottom. And we can see that is the bottom on the 2D view. And basically going to run those exact same tool paths on the bottom side. So I'm going to do a roughing pass using that 1/4 inch cutter. Rectangle out here. And coming in, doing the same thing for a finishing toolpath. All the same parameters were set from the previous one, so I'm just going to select calculate. And this time I'm going to click and choose to preview all sides. So again, for this rotational flip, it's a manual entering in. It's not, we're going to have a total of 4 files, 1 roughing for the top, 1 finishing for the top, 1 roughing for the bottom, 1 finishing for the bottom. We would run the tool paths or the 2 tool paths for the top side. Once that is done, issue a command in the ShopBot console to issue the rotation of the indexer 180 degrees, and then we could run the opposite 2 files. So here is now previewed running top side and the bottom side toolpaths as one. Got a very thin layer that there's really nothing there. That's just virtually not there. Now, if we did not have an indexer, we would be able to run and set indexing pins on the outside of this, and I would just draw in a 3/8 diameter circle off on this side, then off on the other side. Then drilling those holes into the top side of the material, and then making those identical holes into my table surface. So when we go to flip, it is a manual flip and indexing this just the same. So that is how that works and how that goes there. So again, taking a look at the 3D view and the preview, we've done top side and bottom side. Now, what are we going to do about this mirror on both sides? For this, basically, we're going to do we would do exactly the same thing, only rotating off to the side. So just quickly demonstrate what this is. So I'm going to open up another file. And this time, the X, making things up, I go now, 2 1/4. I'm sorry, I'm going to make the X 6 inches and the thickness of 3. Now when we come in to import this model, I am going to import the front side, which is rotating that off to the side, and I will set this to be center. So it is, what is center? There we go. I'm just going to click the center in model. I'm just curious to see what happens when we check that button there. I'm going to say OK. Ah, isn't that nice? So what it has done there is automatically brought in both sides for us. So at this point, going to run the same type of scenario and the same type of tool paths, with the Z0 still being at the center of the rotation, which is down here, and the XY being in the center of the material. No XY or Z value changes would have to be made from this project or this job to the next. So running this exact same toolpath across the, as we did on the top and the bottom of the other one, run that here as well. I might limit the depth of the carving to only the model itself rather than going all the way out, which will prevent us from having to go all the way down because one side would already have been removed. And to do that, I'm going to simply select the 3D model and choose to do a create vector around that model. It did pick up this antenna there, so I'm going to do just a quick little node editing to get rid of that. So node edit, it's doing a sweep selection and just going to get rid of these items there. So at this point, I will do a finishing and roughing on just the selected vectors there. Now, I should have paid attention. You do have a little bit of math to understanding where this is sitting in the surface of the model. So the reason for this vector here is this 1/4 inch cutter is not going to be allowed to go out beyond that vector, which means that it will not go all the way down the full height of that material, which you probably would not have enough bit length to get 3 inches down there. So just do a preview. So essentially what we have done is created two-sided machining jobs to create a 4-sided indexed machining method. So this is, again, it's the reason why it's called 3+1, is we are positioning X, Y, and Z 3 plus our 1 main indexed pass. So now I'll do a preview of what this looks like. I must have had a an offset boundary listed here because I did say that that bit was, or that vector that we were creating here was not allowing that bit to go out beyond. In this case, it did. It allowed it to go beyond the pass, and I probably would not have had this bit length and would have crashed the collet into the top of this material here. So coming back into here in taking this boundary offset down to 0 and recalculating. The beauty of preview could save you so much aggravation and time. So I'll reset all of this preview and do a preview all. So there is the 3D on the one side. We would do the same on the opposite side. And again, just doing, in this case, we'd rotate 90 degrees and 270 degrees on our indexer, or again, using a manual method by drawing some 2-dimensional pins or circles on the outside of the model to where we could use that as a manual flip operation. So any questions? There's a lot that we that I showed out here. I don't know. We'll definitely have this recorded. You could watch it again. But it is all about index machining and being able to just index and flip the part around at different angles and orientations to be able to machine it from 1, 2, 3, or multiple sides through the import of the vector. You could also import it based on an exact angle rather than specifying the right, left, bottom, or top. So if you needed and knew that it was able to get more detail out of one sides, you could get it from that angle. So just to keep everything kind of aligned when you're flipping on the indexer and rotating around is keeping the orientation of X, Y, and Z. And at this point is the reason why I set the job size up to be, should have done it here, to the center of XY position, and then also to the machine bed, which is really the center of our index turning. So it is somewhat difficult to understand the first time you do it, but after you do it 1 or 2 times, you'll be like, oh, why did I ever have difficulties in this? It's a hard one to understand. It's a hard one to even grasp until you've done it once or twice.